All right, let's get into it. We're going to go back in time about 50 years to look at one of the most talked about and, frankly, controversial studies ever published about the future of our planet. Back in 1972, a team at MIT used a computer model to ask a really big question. Can humanity just keep growing forever on a planet with finite resources? What they found was a bombshell then, and today, well, it's a message that's pretty hard to ignore. And boom, this right here, this is the conclusion that kicked off a huge firestorm. This isn't some gentle warning, It's a stark prediction of overshoot and collapse. The key takeaway isn't just that there are limits, but that the path we're on means we might not see that final wall until we're flying right into it. So let's break down how in the world they came to this staggering conclusion. So first, you got to understand the core problem that the book lays out. It's basically a collision course between two massive forces, what we can call the engine and the wall. To get a grip on the engine, we have to wrap our heads around something our brains are just not built to understand intuitively: exponential growth. See, we think in straight lines, linear growth, right? You add 2 plus 2 plus 2. But exponential growth is all about doubling. 2 becomes 4, becomes 8, becomes 16. And that doubling, it's sneaky because the numbers get crazy big, crazy fast. The old legend of the Persian chessboard, which the book uses, is the absolute perfect way to picture this. The king thinks it's a small request. 1 grain of rice? Come on. For the first bunch of squares, it's nothing, totally manageable. But because of that relentless doubling, long before the board is even full, the numbers are just astronomical. The king goes from having more rice than he knows what to do with to being completely broke in just a handful of moves. That sudden cliff, that's the danger of exponential growth. So what's powering this exponential engine in our world? The model says it's 2 main positive feedback loops. You can just think of them as snowballs rolling downhill. First, the more people there are, the more babies are born, which, you guessed it, leads to even more people. And second, the more industrial capital you have, factories, machines, the more stuff you can make. And a chunk of that then gets reinvested to build even more capital. These 2 loops are the twin engines driving our whole global system forward. So what happens with this unstoppable engine of growth starts running up against the planet's very real, very solid limits? The model really zeroes in on 3 big ones: food, resources, and pollution. Let's start with food. Look, there's only so much land on Earth you can actually farm. This chart, which is based on the book's data, shows that as the population grows exponentially, the amount of land we need to feed everyone just skyrockets. You go from a situation that looks totally fine, like we have tons of room, to a really serious shortage in just 1 or 2 doubling periods. It's the chessboard problem all over again, but this time it's with our dinner plates. Now this is one of the most mind-bending parts of the whole thing. It totally reframes how you think about resources. Okay, so if we just keep using copper at the same rate we were in 1972, a flat, static rate, the known reserves would last 36 years. Fine. But we're not using it at a static rate. Our use is growing exponentially. And the second you factor in that growth, the lifespan of those exact same reserves just plummets to 21 years. It shows we're burning through our planetary savings way faster than our linear brains think we are. The pollution limit is maybe even scarier, and that's because of delays baked into the system. The book uses the pesticide DDT as an example. Let's say we get it together and ban DDT everywhere, today. Stop using it completely. Because of how it works its way through the food chain, the model shows that the amount of DDT in fish will actually keep going up for more than 10 years before it even starts to come down. What that means is, if we wait until the problem is obvious and painful, it's already too late. We've locked in years of it getting even worse. And this brings us to the big one, the question everybody asks. I can almost hear you thinking it. Okay, but what about technology? Can't we just innovate our way out of this? Well, the researchers decided to put that exact idea to the test with their model. Okay, so let's run a simulation. For this first test, they basically told the computer, assume we've cracked the code. We have unlimited resources. Maybe through something like fusion energy, we can mine asteroids, recycle everything perfectly, you name it. The resource problem is solved. And at first, hey, it looks fantastic. The resource limit disappears, industry keeps roaring, and the collapse we saw before is totally avoided. It looks like a perfect tech fix. Problem solved, right? Well, Not so fast. By getting rid of the resource limit, the industrial engine just went into hyperdrive. Growth sped up so much that it created a brand new problem, one that was even worse. A pollution crisis so massive that it brought the whole global system crashing down anyway. All they did was swap one cause of collapse for another. It's like plugging one leak on a bursting dam only to have the pressure blow out a whole new section somewhere else.
Okay, round two, let's try again. What if we have the whole shebang? What if we have unlimited resources and we invent some magical pollution control technology that just scrubs the air and water clean? They plugged this super optimistic scenario into the model to see what would happen next.
And you know what? It's the same brutal pattern. Growth surges on for a bit longer, but this time it just slams headfirst into the next limit, the finite amount of farmland on the planet. A global food crisis causes the collapse this time. And this is probably the model's most chilling lesson. In a system that's hell-bent on growth, technology doesn't actually remove the limits. It just helps you hit them going much, much faster.
So, if throwing more and more technology at the problem isn't the silver bullet, then what is? Well, the book argues for something completely different, a new path, the path to equilibrium.
So what does equilibrium even mean? It sounds kind of static, maybe even boring, right? But that's not it at all. It's a dynamic state where we intentionally keep population and industrial capital stable. The birth rate matches the death rate. New investment is just for replacing old stuff that wears out. It's all about finding a controlled balance, not stopping human progress in its tracks. This really boils it all down, doesn't it? It shows the two fundamental paths in front of us. The one we're on, the growth model, is basically hardwired for that overshoot and collapse scenario we've seen over and over. The alternative is to consciously manage these powerful forces of growth, to create a stable, sustainable state that can actually last. Now, getting there would mean some really big, deliberate changes. We're talking about stabilizing population and our industrial footprint. It means we start aiming our incredible technology at making things more efficient, more durable, more sustainable, not just making more stuff. And, maybe most importantly, it means shifting what we value as a society, away from just piling up material goods and toward things that actually improve our lives without breaking the planet. You know, things like education, the arts, and healthcare. But hold on. Does a world in equilibrium mean a world where everyone is poor? The model suggests the absolute opposite. The researchers actually ran a simulation of what a stable world might look like, and the average income per person came out to be about $1,800. Now, that may not sound like a lot, but you have to remember, this is in $1970. Back then, that was triple the global average income. Sure, it was about half of the average American's income at the time, but it suggests a sustainable future isn't about poverty for all. It could actually mean a much better material life for the vast majority of people on Earth. And in the end, this is the question that the limits to growth leaves us with. It's a choice, really. A choice between two kinds of limits, the ones we choose for ourselves with foresight and discipline, or the ones that nature imposes on us, suddenly and without mercy. Now, 50 years later, in a world that has pretty much stayed on that same exponential path, well, that choice feels more urgent than it ever has.